Hello, welcome to our AP Chem tutorial. This is presented by Amber, Kavya, Amy, and Michelle. We will be demonstrating how to set up a titration lab using drop counters. Through titration, we can find the quantity of the titrant needed to neutralize the analyte, the substance being titrated. Using the volume of the titrant added, we can calculate the concentration of the analyte.
Titration is the slow addition of one solution of a known concentration, called a titrant, to a known volume of another solution of unknown concentration, called an analyte, until the reaction reaches neutrality, which is often indicated by a color change.
First of all, before we start the setup for the lab, make sure we have everything that we need. That is, you'll need your drop counter, a 50 milliliter buret, a clamp, a right angle clamp, a stir plate, a support rod, a 50 milliliter beaker, a pH sensor, a stir bar, and of course a spark. You'll also need distilled water and standardized solutions with pH of 4 and 10 to calibrate the pH sensor.
To calibrate the pH sensor, first connect the probe to your spark. Click on pH and then click on Show. Click on the Tools button on the bottom right-hand corner and then click Calibrate Sensor. Change the measurement to pH and make sure that your calibration type is 2-point. Take your pH 4 solution and put it in a small beaker. Unscrew the pH probe from the bottom cap and put your pH probe into the pH 4 solution. Make sure that on your spark it says that you are calibrating your sensor to a pH 4 solution. Press Read from Sensor and then take out the probe and rinse it in distilled water. Prepare your pH 10 solution and also put it in a small beaker. Take your pH probe and dip it into your pH 10 solution. And make sure that your spark says it's a pH of 10. Our spark says a pH of 7, so we're going to go ahead and change that. Enter 10 for 10, press OK, and there we have a pH of 10. Press Read from Sensor and it's calibrated. Press OK. And once you're done with that, put your sensor back into distilled water to rinse off, and then cap it again. Press OK, and now your spark is calibrated. So here's Michelle, and she's going to set up the lab. Right now she's tightening the screw on the drop counter, and she's going to put it on the support rod, which is mounted on the stir plate. That's been mounted, and now she's holding the pH probe. She's unscrewing it from the bottom cap, and she's going to slide off the little rubber loop that's on the pH probe so that we can stick the pH probe through the hole in the drop counter so that it can stay still. Just tightening the drop counter to hold the pH probe. And just putting in an empty beaker. Just adjusting the wires so that they don't get in the way. And loosening the drop counter slightly so that she can slide it down. This is so that the pH probe is going to be inside the beaker so that it will be touching whatever solution that we're going to be putting in. Tightening the screw, and right now she's holding the 150 milliliter buret, and she's holding the clamp. She's adjusting the clamp so that it holds the buret in place. Now she's going to mount the buret on the support rod, just sliding it down from the top, adjusting the wires out of the way, and making sure that the end of the buret where the drops come out is going to be directly above the place where the drops will be counted. Here we're using an unknown concentration of hydrochloric acid. We're using 100 milliliters, and that's going to be our analyte, which is going to be poured into the bottom beaker. Next, we'll add 2 drops of indicator solution, 1, 2, and a stir rod. We're turning on the stir plate so that the stir rod mixes the indicator into the hydrochloric acid. Right here, we're slowly turning the little screw at the bottom of the buret and letting out drops one by one. Each of these drops is counted by the drop counter and will show up on the graph of your spark. So we're just going to let this experiment run. Let the drops keep on coming down into the acidic solution, and slowly the acidic solution will start to turn purple. This is the indicator solution working, and the more purple it is, the more basic the solution is. This is the final result after a complete titration. The solution in the beaker is now purple. So here's the graph that we have from our spark. It's a graph of drop count versus pH, and from this graph we can tell where the equivalence point is. So from a graph like this, the equivalence point is where there's a change from concave up to a concave down. And that's going to be at the middle of the graph here. At the equivalence point, the moles of acid equals moles of base. So we know that for this reaction, the equivalence point is at a pH of 8 at about almost 500 drops.
In this lab, we learned how to set up a titration lab where we titrated a substance with unknown concentration, called an analyte, with a substance that we did have the identity of and the concentration, called a titrant. By observing the drop count versus pH graph that we recorded on the spark using the pH probe and drop counter, we found the point where the solution is neutralized, also called the equivalence point.
At this point, the x-coordinate of the graph tells us the pH at the equivalence point, and the y-coordinate tells us how many drops of the titrant were added.